Okay, so welcome to lecture once again, guys. Now, in this lecture, I'll be talking about RNN, a recurrent neural network. So, see, guys, we have already discussed about a neural network, and whenever we talk about a neural network, we talk about input, and then obviously it is going to update our weights in a backward propagation, which is eventually called as learning, and then I will be able to get a output. That's completely fine. But whenever we talk about a neural network, it will not be able to retain anything from a past. Simply means that every time whenever we try to pass an input, so that input will be disconnected from the input or the output that we have given before, right? Before. And it is going to create a problem. So what kind of problem it is going to create? So basically, whenever we try to talk about textual data, whenever we try to talk about a speech or time series based data, over there, obviously, there will be a dependency with a past. So whatever we have done in a past, we have to propagate, or we have to put, or we have to give even that information. Unless and until that information is not available, it will not be able to use the past information or the past memory, and based on that, it will never be able to give the output. So every time it is going to technically give the independent output. Now, this was a problem. This was a problem with respect to a neural network, and this is where, so researchers have introduced a network called as RNN. A full form of this RNN is basically recurrent neural network. So RECURRENT, recurrent neural network. So they have proposed, basically, they have proposed that what if we are going to pass not just a current input, but we can try to pass something even from a past. In that way, we will end up building a memory, or in that way, we will end up providing a previous context to a network. And obviously, when network will try to give me an output, so it will try to consider my previous memory or my previous input or my previous learning as well. It is not going to consider my current input as an independent input. And this is where the concept of a recurrent neural network comes into a picture, which you are going to use to solve multiple problems with respect to a text, with respect to a speech, or with respect to a time series. So wherever we have our dependencies with respect to a past, right? For example, if I'm going to write maybe a line called as I love machine, right? And then dash, 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 dash. So obviously I have to do a fill in the blanks, right? So maybe my network is supposed to predict that what is going to be the next word. Now, whenever my network is supposed to predict what is going to be the next word, obviously it is supposed to consider the previous input. Unless and until it is not going to consider a previous input, it will not be able to give my next output. And this is where the phenomena or the concept of this neural network comes into a picture. So they said that okay, so whenever you are trying to design a neural network, for example, I have a input over here or input layer over here, and let's suppose we have a hidden state, and let's suppose we have a output layer. Fine. So I believe we all understand this particular part in terms of a neural network basic. I have already discussed about it, and if you have not gone through this entire concept, so please try to watch my previous lecture where you will be able to find out a complete end-to-end derivation in a detailed way for a forward propagation as well as for a backward propagation. So here, let's suppose I'm trying to design this neural network. Obviously, I will be having some input. So let's suppose I'm trying to give input as x1, and I have input as x2, and I have input as a x3. So every time I'm going to pass this input, and obviously it will go through my hidden layer, or you can say my hidden network. Just do all the connections, and then eventually I will be able to get the output is equals to y hat, let's suppose. Yeah, y hat. So I'm trying to give some input, and then I'm going to get some sort of a output over here. That's cool. That's completely fine. But here, so whenever I'm trying to get a output, there is no dependencies between the previous input, right? So let's suppose I have passed a value of x1, x2, x3. I will be able to get y. That's cool. That's completely fine. But next time, whenever I'm going to pass a new value of x1, x2, x3, for example, I love machine. This is something which I'm trying to pass over here. it won't be able to understand that what I have passed last time. And if it is not able to understand what I have passed last time, it will not be able to consider it. Simply means that we are not building any kind of a memory. Now, what people have proposed over here. So they said that okay, so maybe we can do one thing. So we are trying to pass the current input. That's cool. That's completely fine. But what if we can try to pass some input even from a past learning? What is the meaning of it? Yeah. What is the meaning of it? So maybe, right, this was the proposal basically. So maybe what we can do. So here, let's suppose x1 at time t, 2 at time t, 2 at time t, right? And then here, so we have a hidden state, let's suppose ht, and then y at time t we are going to get. Now next time, right, as of now we are living into a current situation, time t, yeah. Now next time, whenever I will try to pass x1, x2 and x3, yeah, x1, x2 and x3 over here. So what we are going to do, so maybe we can try to pass this one as an input, right? So we can try to pass this one as an input when this will be t plus 1, t plus 1, t plus 1 means next time. So this was a hidden state output we are trying to pass into a next state, and obviously it will be a part of your entire neural network. So next time, whenever you are going to get y t plus 1 at time t plus 1, whenever you are going to get the output, so as you can see, we have passed a previous input as well, a previous hidden state output as a input. Yes. So previous hidden state output as a input we are trying to pass, and obviously this will be having an idea, this will be having an understanding, because ht, when we are going to get this hidden state, whenever we have passed x1 at time t, x2 at time t, and x3 at time t. So basically, this will be having an idea that what we have passed, and with this, we are trying to pass it in a current state, right, at even time t plus 1. So we are trying to pass ht, which is going to be the previous hidden state value. So in this way, it will be able to build a memory. Yes, in this way, it will be able to build a memory. It will be able to understand that, okay, last time this was something which has been passed, and next time, whenever I'm trying to give some sort of a output, so let's try to consider even a previous input. And that was the whole understanding about a recurrent neural network, basically. And in this way, you will be able to solve a speech problem. You will be able to solve a text problem. You will be able to solve eventually a time series based problem or time dependent problem. So where previous input is required. But again, there was a problem. The problem was very simple. The problem was that when your input is going to be very, very long, right? When your input, or again and again, you will keep on passing the input, and obviously in a backward propagation, it will try to even learn. It will try to adjust the weight in between. So when your context or when your memory will keep on increasing, or you are trying to solve some problem, so where your context is very, very long. So in that case, it is going to face a vanishing gradient problem. What does that mean? So vanishing gradient problem means it will not be able to retain, or it will not be able to adjust a weight with respect to the very, very long context or long memory, you can say, in other words. And that was a problem that we have been facing. And to solve that problem, people have introduced a network called as LSTM, long short-term memory, or you can say another network called as GRU, a gated recurrent unit, basically. So this was again another variant of a RNN. You all will be able to find out, which I'm going to discuss in your upcoming lecture. But yeah, so as of now, I believe understanding about a recurrent neural network is pretty much clear to all of us. In my next section, so let's try to talk about LSTM, and let's try to talk about gated recurrent unit network separately in a separate lecture. So with that, thank you so much, everyone. Take care, and see you again in my upcoming lecture.